this video, I'll be going over the Unit 5 study guide. So in the first part here, we are solving by graphing. Remember, to solve means we're looking for a solution. And that solution is where the graphs intersect visually. But more importantly, like what that represents is an x and y pair, where if I plugged the x and y values into the equations, it would work. It would make both of them true, and it would satisfy both equations. So let's get into it and start graphing. I'll do some quick reminders on graphing here, so feel free to fast forward. But this -1 is our b value. So this is going to be the y-intercept. So here's my y-axis. I'm going to put a point at -1. The -1/2 is my slope, also known as m. We do this using rise over run. So this means I'm going to go down 1 and over 2 from that y-intercept. And I'll just keep repeating this slope until I have a lot of points. And when you run out of space, you can even go backwards to get more. Just make sure you keep that slope going in the same direction. For this second graph, we have a b value of -4. So that will be our y-intercept this time here at -4. And a slope of 1/4, which means we're going up 1 and over 4 from that y-intercept. So up 1 over 4 and so on. I'm even going to go backwards a little bit here to get more points. And here is our point of intersection. So we would have to go over 4 and down 3 to get to this point. So my solution is 4, -3. For number 2, we have a y-intercept of -4 for the first equation and a slope of 3. So we're going up 3 over 1, up 3 over 1, and so on. All right, and then for our other equation, we need to solve this for y first. So our b value is 3, and our slope, our m, is -2/3. So here's my y-intercept, and I'm going to go down 2 over 3, down 2 over 3, and then I'm going to go backwards some. So for the x value, I'm going over 2. For the y, I'm going up 2. So my solution is 2, 2. For number 3, we start getting into some quadratics. So for this first one here in blue, this quadratic, I can tell it's a quadratic because of the x squared. So when we're graphing a quadratic, we need to first figure out our axis of symmetry, or our AOS is what I sometimes will abbreviate this to. The formula for axis of symmetry is x equals -b over 2a. My a value in this case is 1, my b value is -4, and my c is 2. So when I substitute these into the formula, I'll have -4, or just 4 on top. And then my a is 1, so I have 2 times 1 in the bottom. And this just equals 2 overall. So that means my axis of symmetry is at 2 on the x. So this is x equals 2. So that's going to be the middle of the parabola, or the line of symmetry that goes down the center and through the vertex. For my vertex, I'm going to substitute this x value into my original function. So when I work this all out, I end up getting -2 overall. So that's my vertex, right? It's at 2, -2. From here, I'm going to use my step pattern to get the rest of my points. Step pattern is always going to be 1, 3, 5, 7, and so on. That could keep going, 9, 11, 13, forever. But we don't really have enough space for all of that anyways. And that is really simply because my a value is 1. If my a value were 2 or 3 or 4, I'd have to multiply all of this by whatever the a value is. Then we will connect these. Now, when you make your parabola, try not to make it too straight or pointed like a V. We really want it to be rounded here at the bottom so that it doesn't look like an absolute value function. That's good enough. And then for the last line here, we want to graph this one. So this is a linear function. I can tell because there's no x squared, it's just x to the first power. So we have a y-intercept of 2 and a slope of 1. We have 2 points of intersection this time since it is a quadratic. Our first one is here at, we didn't really go left or right at all, so it's 0 and then up 2. My second one is over here if I went to the right 5 and up 7. I know I don't have a second solution line on mine, but you should have space on yours for the second solution. So 5, 7 is the other solution. All right, in number 4, we are dealing with 2 quadratics this time rather than just a quadratic and a line. And so in this one, they're actually only going to intersect at one point. It is possible for them to intersect twice if there was 2 quadratics, but that's just not one that I gave you this time. So let's do this first one. We are going to first find our axis of symmetry. So don't forget that formula. Put it on your note card. But first, we're going to find negative b over 2a. My a is negative 1. My b is 2, and my c is 2. So negative b will be negative 2 on top. Since a is negative 1, we have 2 times negative 1 on the bottom. So really, we have negative 2 over negative 2, which is positive 1. To get the y value, I will substitute this in to the function. And so we end up getting 3. So that means my vertex is at 1, 3. And I will highlight this for us. Let's go ahead and plot that point. 1, 3 right here. And now we're going to do the step pattern, which because the a is negative 1, my step pattern is going to be going down. Let me write that step pattern up here. 1, 3, 5, 7, 9, so on. Now, because a is negative 1, I'm really multiplying this whole thing by negative 1. Or you can imagine it in your head as just, hey, we're going down on this. So let's go down 1 over 1, and we can just go ahead and do that on both sides. And if it's helpful, you can draw your axis of symmetry through here as well. And then now that we've done 1, we will do the 3. The next step is 3. And then 5. For the other quadratic, we will follow this same process. This time, though, the a is positive, so our parabola will be facing up. But just like before, we have a, b, and c given. So my b is negative 2. So on top for my formula, instead of negative b, since b is already negative, we really end up with positive 2 on top. And then a is just 1. So we have 2 times 1 in the bottom. So we have 2 over 2, which is just 1. Plugging this back in, we just have x squared minus 2x plus 4. So my vertex is at 1, 3 for this parabola as well. They have the same vertex and the same axis of symmetry. However, the a value is different, so it's positive 1. So we're going up 1, up 3, up 5, and so on. I don't really have enough room to go for the 5. So our point of intersection, there's only one in this case, is right here. This is the point 1, 3. And you can pause the video here if you need to take a look. But let's go ahead and check out number 5. With substitution, we are taking the y or the x for one equation and substituting it into the second equation. So in this particular one, the first equation is already solved for y. And so I think it'll be easiest if we just take the 5x plus 7 and substitute it in for y for the second equation. So I'm going to rewrite negative 3x minus 2y equals negative 12. And because y equals 5x minus 7, that is going to go in place of y. From here, we're just going to solve it. And I end up getting x equals positive 2. To find my y value, I simply substitute it into either of the equations. It doesn't matter which one, but the first one is going to be much easier. So my solution is at 2, 3. For number 6, we're still using substitution. However, neither equation is solved for x or y like it was in number 5. We had this y equals equation. We can also do this for x equals. It doesn't matter. But because I'm thinking in this first one, it would be much easier to solve for the x. Let's go ahead and just subtract 3y from both sides. So I end up having x equals negative 3y plus 1. Because I solved for x and not y, I have to substitute this in for x in the other equation, not y. So let's go ahead and do the substitution here. This time, unlike the last one where I found x and then had to substitute in for y, this time I found y and we're going to substitute in to find x. So my solution is negative 8, 3. Be careful with where you place them because this time you found x second. It's tempting to just put the number you found first, but we do need to make sure it's in the order x, y. We're still doing substitution, but this time we have a quadratic involved. It really doesn't matter which equation you plug into the other. So for example, I could take this one, solve it for y by subtracting 4x to both sides. And then I could take this part here and substitute that in for the y over here. But that one would be just as easy. But for future reference, instead of solving this one for y, we could also just as easily take this expression here and substitute it in for y in this one. Really doesn't matter which one you do, but I wanted to show you that both are an option and you'll get the same answer. But here's how I'm going to go about this. I'm going to take this quadratic and substitute it into y for the second equation. I'm going to replace y using parentheses with that entire first quadratic where it said y equals. Now I'm going to start simplifying and solving. So now I'm going to factor this. There is a GCF in this case. So if I were to factor out negative 2, this would be x squared. My signs are going to change. This would be plus 4x and then plus 4. Now I'm going to factor this part even more into two binomials. So I'll use my diamond method. I need numbers that are going to multiply to 4, but also add to 4. And it's just coincidence that they're both a 4 in this case, but it does turn out to be 2 and 2. So we have negative 2 and then x plus 2, x plus 2. My last step to solving is to look at each factor we put in individually. So we have this x plus 2 right here equaling 0. So x equals negative 2. And we also have this other one doing the same thing. They're not always the same number. So just be careful. Sometimes you do really have to do it twice to get the same number. But in this case, it's okay. We don't have to do it twice. This just means we have one answer in the end. Let's find y. I'm going to use the second equation because it just looks a lot easier. So my final answer is negative 2, comma 6. Let's take a look at number 8. We're using substitution here as well, but they are both quadratics this time. So I'm going to take 3x plus squared minus 12x plus 1, since that's what y equals, and substitute that in for y in the other equation. To solve, we really need to get all of our like terms combined across the equal sign, and we need it to equal 0. So I'm going to choose to add x squared to both sides. You could just as easily subtract 3x squared instead, but then you're going to have to deal with a negative a value, and it's just a little messier than is necessary. In one step, I'm also going to go ahead and subtract 8x from both sides and add 15, so that all of these cancel out on the right side. This has a GCF of 4, so I'm going to factor that out first. So I have x squared minus 5x, since that would multiply to the negative 20, and then plus 4. Now I can factor using my diamond method. This needs to multiply to 4, but add to negative 5. So my two magic numbers end up being negative 4 and negative 1. So when I factor, I have x minus 4 and x minus 1. From here, I use each of my individual factors to find x. So in this case, x equals 4. In this other one, x minus 1 equals 0, so x equals positive 1. So now my last step is to find y. Now this time I have two different x's, right? So I need to find y in both scenarios. I'm going to just use the first equation for both. But we end up getting y equals 1. For the other x value, we're going to substitute 1 in, and I get negative 8. Be careful with how you pair these together. So like this x value of 4 goes with y equals 1, right? And then the y value, or the x value 1 goes with negative 8. So make sure the x and the y's are paired in the correct like order. So my first answer is going to be 4, 1, because 1 is what I got when I substituted 4 in, right? And I do have a second solution. So let me make some space for that. The second one is 1, comma, negative 8. Let's take a look at elimination. This is my favorite method. Our goal is to get either the x's to cancel or the y's. Neither are going to cancel as of right now. So what I'm going to do is multiply this top one by negative 3 with the goal of canceling my y's. So once I multiply by negative 3, I get a new system. So I'm going to rewrite the full thing after multiplying by negative 3. And then I'll just go ahead and copy down the second equation. All right. Now, if I add these together, the y's cancel. I get x equals 2. To find my y value, I will simply substitute this into either equation. I'll just go with the first one. So my solution is 2, comma, negative 5. For number 10, we're going to have to multiply both of the equations. 4 does not multiply to make 7, and vice versa. Like none of these numbers can multiply into each other. So I can either focus on the x's or the y's. Because the x's are smaller numbers, I think I'll go with that so that I can avoid having too large of values to work with. So I'm going to multiply this top one by 4, which will give me negative 28 for the x. And I'll multiply the bottom one by negative 7 so that I get positive 28 for the x. We are going to add these together. This ends up giving me -2 when I divide both sides by -95. Let's find x. Doesn't matter which equation you use. So my solution is 1, -2. Make sure the x goes first. So here's our solution. The first step here is to choose any two equations to start with. It doesn't matter what you choose, but typically we choose ones that are going to be easiest to find a variable that cancels. Let's do the first and third equation. So we're going to go with this one and this one for equation A. So in A, I'm using 6x minus 5y minus 3z equals 6. And then I'm going to do -3x plus y plus z equals 6. Notice that a lot of these would be easy to go ahead and cancel out. I think I'm going to multiply this bottom one by 2 so that I have 6x and -6x. So for this equation A, I end up having -3y minus 1z equals 18. Let's go ahead and focus on the other two. Now, you can choose any two again, but we have to make sure we use the second one since we haven't used it yet. And I am going to have to cancel the x's again since that's what I did the first time. So I think I'm actually just going to do the first one again with the second one. And so this is how I'm going to get my equation B. I'm going to multiply the second equation by 6 so that I can get the x's to cancel. But I end up having 19y plus 33z equals -114. For my last step here, which is going to be my third round of elimination, we are going to bring the equations from A and B together. So because I don't have any x's anymore, I can cancel whatever variable I want. I'm going to cancel the z's, so I'm going to multiply this top one by 33. So you might end up dealing with some larger numbers in this third round. That's pretty common. Don't let it worry you too much. We're going to add these together. My z's cancel. When I do that, I get -6. So my y is -6. I still need my x and z. So all the elimination steps are done. You have successfully completed the hard part here. But let's go ahead and find the rest of the variables. So the first variable I have to find is actually z. I can't find x yet because I would have to go back to the original for x. So the first step in this process is to substitute y into either equation A or B. So we don't want to go all the way back to the beginning yet. We kind of have to go back in layers. So you just choose one of these. The first one looks easier to me. To find x now, I can use one of the originals. And I'm actually going to use the second one because I'm looking for x. And in this equation, the x doesn't have a number in front of it, so I know it's going to be easier. So now I know x, y, and z. So we'll put that in order of x, -4, y, -6, z, 0 for my final ordered pair. So with this word problem, I'm going in assuming that you have already read it. I'm just going to kind of look at some key points. So we're dealing with a field trip. We have two different classes going on here. We have the seniors at high school A and high school B. We have one scenario where they filled 8 vans, 8 buses, and we know the total, but we don't know how many students are in each. And then high school B had 4 vans and 1 bus with 54 students. The reason we can do a system is because the vans for both schools had the same number of students in it, and so did the buses. So it's not like the vans equals buses. It just means that high school A, both their vans were the same as high school B's vans, and then high school A's buses were the same as high school B's buses. So we're going to create a system with variables. What we don't know is how many students were on each van and each bus. Okay, this leads to 2 equations. One is going to be for high school A. They had 8 vans. V would be the number of students on each van. So if there's 10 students on each van, I would do 8 times 10, right? If there's 8 vans. So that's why I'm multiplying 8 with V. And then we know that there's also 8 buses for a total of 240. So this is high school A. High school B had 4 vans and only 1 bus for a total of 54. To solve this system, we're just going to get one of the variables to cancel. Doesn't matter which one. I'm going to multiply this one by -2. I'm choosing as elimination, but you can use substitution if you like, or whatever method that you prefer. My last step here is to find my V. So I'm just going to do that in this little space here. I have you writing your answer as a sentence here because I want to make sure you understand the significance of 8 and 22. Like, what do they mean? And so here's a sample sentence of how you might say this. For both high schools, each bus held 22 students and each van held 8. Let's move on to some inequalities here. This is going to be almost like the beginning when we were graphing. This time we're going to have some shading involved. So in this first equation, I'm going to go ahead and solve that for y. And it is very important for me to point out that anytime we divide by a negative, we must flip the inequality sign, so my greater than becomes less than. So I've got 5 halves x, it's positive since it's a negative over a negative. Same with this second term here, we get positive 4. So my y-intercept is 4. I'm going up 5 over 2. And before I connect these, unlike the front, I want to make sure that this should be like whether it should be solid or dashed. Because this symbol does not have the equal bar, this one is going to be a dashed line. Now we have to think about shading. This is a less than symbol, which means I'm going to shade below the line or where everything is less than the line. So this would be below. So here's what that would look like. All right, let's do this red equation. It doesn't even have an x, which means there's no slope. So this is a horizontal line at -3, and it is a solid line because it does have the equal bar. And for this one, I'm going to shade below as well. I'm kind of ignoring the blue when I do this. My solution is going to be in this overlap region, which I do want you to be labeling, so that way it's very clear to me what your solution is. So this whole region is the solution. Anything in this area would be an answer. For number 14, we are going to have to solve both of these. So I have y is greater than or equal to, I have to flip this, right, since I divided by a negative, x minus 4. So y-intercept is at -4. I have a slope of 1, and this is going to be a solid line since it does have an equal sign with it. And we are going to shade above because this is a greater than symbol. Now let's do the other one here. All we really have to do for this one is divide by 3 in order to solve it for y. When you divide by a positive, you do not have to worry about flipping anything. So this will be a normal inequality where nothing changes other than the numbers. So I get y is greater than x plus 3. I'm going to scooch this up. All right, my y-intercept is at +3. We have a slope of 1, just like this other graph. These are parallel lines. So if this were not a inequality, like with shading, this would be no solution because these lines are never going to intersect. However, because they're inequalities, the shaded regions do overlap, so we can solve this one. It's not no solution. So we can go ahead and shade this one above the red line. So my solution region is up in this top area. All right. We are on to a word problem with inequalities. All right, I'm assuming you already read this, so I'm just going to kind of skim over the important parts here. But she either runs 6 miles a day, that's one option, or bikes 10 miles a day. She wants to hit 200 miles with at least 15 of those days running. We want to know the number of days it would take to accomplish this. So those are my variables, right? The number of days in each activity. So for my system, the first inequality is just going to be about like her goal with the minimum distance. So if she ran 6 miles a day, I could do 6x, x being the number of days. So we'd get her total like distance that she's ran. And then if I do 10y, because she bikes 10 miles a day, I'll know the total distance she's biked after, plugging in the days. But we know that between running and biking, she wants to hit 200 miles. It says minimum distance. So she's okay hitting exactly 200, but it could be more. So we're going to put greater than or equal to 200. For the second one, we're looking at the actual number of days that she's working out, not the miles, just the actual number of days. So if we take the days running, she wants to run at least 15 days. So we want x to be greater than or equal to 15. This will be a vertical line when we graph it. When you solve it for y, you get y is greater than or equal to, I end up subtracting 6x divided by 10, blah, 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 but I end up getting negative 3/5 x plus 20. Let's graph that one first. I know the y-intercept needs to be 20. I don't think I have 20 lines here, so maybe I just count by 2's. So this would be like, I'm going to use a different color. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So here's 20 on my y-axis. 2, 4, 6, 8. I'm going to make sure I'm counting by the same on my x-axis. My slope is negative 3/5. You can still use that slope as long as you counted by the same thing on the x and y. You don't have to adjust for the fact that we counted by 2's. But that only works if you counted the same on x and y. So here is the line representing total miles that she's ran based on days. Now I'm going to do the one that's the x is greater than 15, and this one is greater than as well. So we will shade, because it's vertical, we're going to shade on the right. There is no above or below in this case. Now we're going to do the shading on the red since I accidentally skipped that. Shading above the red. So this region represents possible combinations of running and biking she could do that would satisfy both goals. So one possible combination of that she could run to meet her goal and bike would be anything from this region, but I'm just going to pick this point here. So one option would be for her to run for 18 days and then bike for whatever that y value was. It was 12. Anything in this overlapped shaded area would be a possible combination, but I chose the 18, 12. The last thing I want to do here is make sure my axes are labeled because I didn't do that yet. So the x is days running, and the y is days biking. I'm going to highlight that just to make it a little bit more clear, and then we are good to move on. All right, we're on to the last page here. Just a couple more systems with word problems. So we have different types of stamps. We have 28 cents and 4-cent stamps, and what we don't know is like how many of each he has used. So let's write our system. The first one can be about the value. So if he uses so many, like X number of 28-cent stamps, we could multiply that, right, to know the total amount of money spent. And because we're working in dollars here, I'm actually going to write this as 0.28. That's 28 cents, right? Written as dollars. X plus 0.04 for 4 cents. Y. He needs at least $1.60. The next equation here is more about the number of stamps, not the value. So between the 28-cent stamps and the 4-cent stamps, he can't use more than 20. So we need the sum of these to be less than or equal to 20. Let's go ahead and graph this. I'm just going to go ahead and write what these are when I solve for y. So this first one could be rewritten as y is greater than or equal to 7x plus 40. The second one, if I solved it for y, could be written as y is less than or equal to negative x plus 20. When I graph these, I need to make sure my y-axis is counting by a value that's going to allow me to fit the entire function. And so I need it to go up to at least 40 on the y-axis so that I can fit this y-intercept. So I'm going to count by 4s. All right, we've got a y-intercept at 40, a slope of negative 7, and I'm going to shade above real quick. For the next inequality here, we've got a y-intercept of 20 and a slope of negative 1. And this time we are shading below. So we end up being in this very small region here. And so one possible solution could be, like, again, we're counting by 4s here, right? So 4, 8. Maybe I do this point here. That would be at 8, 4. So one possible combination would be for him to use 8 of the 28-cent stamps, and I think we said 4 of the 4-cent stamps. So remember, my x-axis here was the number of 28-cent stamps, and my y-axis was the number of 4-cent stamps. All right, we are on to our last word problem here and last problem in general. So we have a Boy Scout camp. We have popcorn, we have large bags, and it looks like small bags. So the small bags, which I'm going to do as X, sell for $4 each. And it's just the number of bags, right? So, and then Y is going to be the large, how many large bags were sold. So in our system, if small bags are $4 each, we'll have 4X. Large bags are 6, so 6Y. We need this to add up to at least $300. So we're going to do greater than or equal to 300. For the second equation, he can also get a badge if he sells at least 60 bags of popcorn. Doesn't matter how many are small or how many are large. So the total between small and large bags, we want to be greater than or equal to 60. So if I were to solve these for y, this first one, if I subtract 4 to both sides, I end up getting y is greater than or equal to negative 2/3 x. And then we're going to have plus 50. For the second equation, if I solve that for y, I would simply be moving the x to the other side. And so I'd have y is greater than or equal to negative x plus 60. Let's go ahead and graph. I'm going to count by 10s, I think, or actually, I'm going to count by 5s. Y-intercept of 50. I'm going down 2 over 3, and we are going to shade above this line. And then for the second equation, we have a y-intercept of 60. So we got 55, 60 right here with a slope of negative 1. And for this one, we are also shading above. So anything in this large region here would be a solution to the system. This x-axis was the number of small bags, and we have large on the Y. The last thing here is to just interpret. So one possible combination, which I'm counting by fives, right? So that would be 5, 10, 15, 20, 25, 30. So we could do 30 small, and this would be 40 large. All right, don't forget to make your note card, write down your test date, all that good stuff. Let me know if you have any questions, and have a great day.